Hello, and welcome to this presentation, Getting Started with the CMA180 VoIP Audio Delay Testing. In this presentation, we'll show how to use the Rohde Schwarz CMA180 radio test set to measure voice over IP audio delay in modern air traffic control radios. Traditionally, air traffic control radios used telephony-style interfaces for transmitting and receiving audio, but modern ATC radios have moved to voice over IP, or VoIP, due to the significant advantages this provides over legacy systems. Interoperability between radios and other system components is based on compliance with the EuroK ED137 series of standards. In VoIP-based ATC communications, audio is received by the radio over an IP connection, and this audio is then used to modulate the transmitted RF carrier. The received packets are first passed through a jitter buffer before being processed and sent to the modulator. This process introduces both fixed and variable delays, and this delay is an important metric when it comes to evaluating the overall quality and usability of VoIP-based communications. Therefore, it's necessary to accurately and efficiently measure VoIP delay, and in this presentation, we'll go step by step through how this is measured using a Rohde Schwarz CMA180 radio test set. The CMA180 can perform VoIP audio delay measurements when equipped with license option CMA-K611. Note that option CMA-K610 is also required to enable VoIP support. The CMA provides an integrated solution. It does not require any additional software, a separate PC, or any external devices or accessories. VoIP over IP packets are sent to the radio under test over a LAN connection, and the radio under test then uses the audio encoded in these packets to modulate its transmitted RF signal. The CMA then receives and demodulates this RF signal and measures the transmit audio signal delay, which is displayed as both current as well as statistical values. Let's go through this again graphically. The CMA180 sends voice over IP packets via its LAN interface to the radio under test. In this presentation, we'll be using a Rohde Schwarz 5200 series air traffic control radio. This radio then extracts the audio from the VoIP packets and uses this audio to AM modulate its transmitted RF signal. Note that the CMA180 also controls the transmit or push-to-talk function of the 5200. This transmitted signal is routed back to the RF input of the CMA180, which then calculates the transmit audio delay. We'll spend the remainder of this presentation showing in detail how to configure and run this test scenario. We'll start with the configuration of the 5200 series ATC radio. The first step is to connect to the radio's web-based management interface. This is accessible either via the front panel LAN interface or via the LAN 5 interface on the rear panel. A username and password are required to access the management interface. It's important to note that a different physical interface with a different IP address must be configured for VoIP traffic. That is, the same interface cannot be used for both management and for VoIP packets. Our next step, therefore, is configuring the interface over which the S5200 will receive the VoIP packets. This is done under the Configuration IP Network tab. Note that most configuration tasks require both write and expert access to be enabled. Select one of the rear panel LAN connectors, LAN 1 through LAN 4, and then use more details to enter the IP address, subnet mask, and gateway for that interface. Note also that this interface must be IP reachable from the CMA180's LAN interface, and this is most often done by configuring both interfaces to be in the same IP subnet. In our example, we've assigned address 192.168.1.120 to the LAN 1 physical interface. Next, we need to go to Configuration Radio to configure the radio parameters. The transmit frequency and channel spacing should be set or verified. In this presentation, we're using a UHF band radio, but for VHF band radios, the frequency is set using an ICAO channel number. In either case, it's important to make a note of this information, since we'll be using these values to configure the frequency ID on the CMA180. Further down, we also need to verify that supported audio interfaces is set to analog and VoIP. The last set of parameters are found under the Configuration Audio VoIP tabs. Here we need to enter the SIP URI in the format SIP:/S5200 at, and then the CMA LAN IP address. We'll use 192.168.118 in our example setup. We should also verify that the SIP port is set to the default value of 5060. When configuration is complete, press the Write to Radio button at the bottom of the screen to write the configuration to the S5200. Changes will not be applied until this button is pressed. Note that the configuration settings will persist through power cycles. No additional configuration or interaction is needed on the S5200 for running a voice over IP audio delay test. Next, let's go step by step through how to connect and configure the CMA180. The CMA180 is configured and controlled through its graphical user interface. This can be accessed via the front panel touchscreen, although a keyboard and mouse can also be used if desired. In addition, the GUI can be accessed remotely over a web browser or using standard remote access clients, such as Remote Desktop or VNC. To configure the CMA's IP address, press the Setup Hard key on the front panel, and then go to the Remote tab. The other important interface setting is ensuring that the RF connector is set to the default RF COM port. This can be checked using the configuration icon in the main CMA180 GUI. After having configured the S5200 through the web interface, as described in the previous section, no additional interaction with the S5200 is needed for testing. The next task is connecting the radio's VoIP interface to the CMA180's LAN interface. VoIP packets will be sent from the CMA to the S5200 over this LAN connection. The RF output of the S5200 is then connected to the RF COM port on the front of the CMA180, and this connection is used to carry the AM modulated RF signal from the S5200 to the CMA. Lastly, the AF or audio frequency out port must be connected to the AF1 in port using a BNC cable. This provides an audio loopback between these two ports. VoIP transmit delay measurements are run under the transmit measurement scenario. Simply click on the global toolbar and then choose TX under the Analog tab. Once the application is started, press the folder icon to toggle between split mode, which shows the generator and analyzer applications side by side, and the merged mode, where only one application is visible at a time. This is the default view of the main TX test screen. To configure a transmit audio delay measurement, the generator icon must be placed into VoIP mode by pressing the VoIP icon, and the Routines tab must be selected to configure and run the test, as well as to view the measurement results. Let's now go through how to configure the generator. The first parameter is the frequency ID, which must be the same as the frequency ID of the S5200. For 25 kHz channel spacing, the frequency ID is the same as the nominal frequency, here 310 MHz. Pressing the link icon to the left will copy this frequency to the analyzer settings. Next, we must match the URI to the settings on the S5200. The SIP field should be set to S5200, and the @ symbol should be followed by the VoIP interface address. In our example setup, this would be the address of LAN 1 on the S5200, which we configured to 192.168.1.120. The AF or audio frequency generator settings are automatically configured when the TX audio delay test is started. Note too that the VoIP, PTT, and AF generator checkboxes must all be individually enabled. Once these boxes have been checked, generator output is started by pressing the play button. If the connection is successful, the generator tab LED will turn yellow. The PTT or push-to-talk LED will also turn yellow, and this indicates that the S5200 is transmitting. The generator can be halted by pressing the stop icon. On the analysis side, navigate to the Routines tab and set the frequency of the received signal. Recall that using the link icon in the generator will cause this field to be linked to the generator frequency. Expected power should be set at least slightly higher than the expected output power of the S5200. Modulation type must be set to AM. Note that this is not the default value. And finally, method must be set to transmit audio delay. To start the measurement, press the play button on the right-hand side of the screen. A pop-up window showing the measurement state and the current measurement result will appear. Note that the number of measurements can be displayed by clicking on the configuration icon and then adjusting the audio delay statistics count under the TX Audio Delay tab. Transmit audio delay measurement results are shown in a table, with a new row being added after each measurement is completed. The table contains the delay value for each measurement iteration, as well as statistical values for average, maximum, and standard deviation. These values are calculated over all completed measurement cycles. Let's end with a brief summary. The Rohde Schwarz CMA180 radio test set provides an integrated one-button solution for measuring transmitted VoIP audio delay. It does this by sourcing VoIP traffic to the radio under test and then demodulating and analyzing the RF signal from the radio under test. In this presentation, we provided a step-by-step example of how to measure transmit VoIP audio delay through a Rohde Schwarz S5200 series air traffic control radio. The only connections required for this test were a LAN and an RF connection between the radio and the CMA, as well as an audio loopback cable on the front of the CMA. And finally, we explained how to configure the necessary parameters on both devices, such as the VoIP interface IP addresses, the transmit frequency, the modulation type, and the statistics count. This concludes our presentation, Getting Started with the CMA180 VoIP Audio Delay Testing. If you'd like to learn more about VoIP testing, the CMA180, or air traffic control radios from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.